All right, let's take a look at a few more properties of logs. This next one is called the power property. And you'll notice that it says log base b of some number a to a power p can be rewritten so that that power p is actually now placed in front of the log and multiplied to whatever log base b of a is. So for example, if I said log base 2 of 4 to the third power, I'm going to rewrite this, and I'm going to take that 3 and place it down here in front of the log, and it becomes 3 times log base 2 of 4. Now I simply have to solve this log and multiply it by 3. So the result would be 3 times log base 2 of 4, which is 2, and that's equal to 6. Okay, our next property that we're going to take a look at is a very handy one. It's called the change of base property. Now, you'll note on your calculator that you only have log base 10, the common log, and the natural log, which is log base e. But oftentimes you're given problems like log base 3. So how do you calculate those using your calculator? You apply the change of base property, which simply says you can change the base of a log base b of x to a quotient of log base a of x, this number here comes on top and is in the numerator, divided by log base a of whatever your original base was, b, down here. So for example, if I had log base 3 of some number like 17, I don't know how to calculate that. I can apply the change of base formula, which says I'm going to take now the common log of 17, and that's going to go in the numerator, and divide that by the common log, which is log base 10, of my old base, which is 3, and that goes in the denominator. Now I can simply punch that into my calculator and find out whatever the power is that I would raise 3 to in order to get 17. All right, our last two properties down here are the inverse property of logs and exponents. And this first one down here says log base b of b to the x power is equal to x. In other words, if I want to find the power I raise b to in order to get b to the x, it's simply x. Let's just do another example. What is the log base 5 of 5 to the third power? In other words, what power do I raise 5 to in order to get 5 to the third power? Well, that has to be 3. All right, our last one here says b to the power of log base b of x has got to be equal to x. Because remember, log base b of x returns the power I raise b to in order to get x. Well, I'm raising b to that power, so it must return x to me. Again, let's just do an example. 5 to log base 5 of 25 should be equal to what? Well, it should be equal to 25. And just as a way of proving this here, 5, what power do I raise 5 to in order to get 25? This whole thing here, this log base 5 of 25, should really be equal to 2. So in other words, 5 squared, again, should result in 25. All right, let's apply all these properties now and take a look at how we can use these properties to manipulate some functions. So this first one says log base 6 of 2 plus log base 6 of 3. Now I recognize that this is an addition problem or a sum, and therefore that sum showed up in that product rule. So I'm actually going to use that product rule backwards here, which says log base 6 of 2 plus log base 6 of 3 is really equivalent to log base 6 of 2 times 3. Well, I know 2 times 3 is equal to 6, and so this is really equivalent to log base 6 of 6. Now, this is another one of my properties which says whatever power I raise 6 to generate 6, well, that just must be equal to 1. So I can go back to my original equation, which says log base 6 of 2 plus log base 6 of 3 must be equal to 1. All right, let's take a look at the next one over here, which says log base 5 of 200 minus log base 5 of 8. And again, I recognize that this is a minus sign, so that I can use the quotient property. And I'm going to use the quotient property backwards in this case. And I'm going to write an actual quotient. So I can rewrite this log base 5 of 200 minus log base 5 of 8 as log base 5 of 200 divided by 8. Now again, I'm going to simplify 200 divided by 8. When I do that, that comes out to be 25. So really what I'm solving here is log base 5 of 25. In other words, what power do I raise 5 to in order to get 25? Well, you know that that's equal to 2. And therefore, my original equation, log base 5 of 200 minus log base 5 of 8, is equal to 2. All right. Now we're getting into a little bit more detailed stuff here. We actually have log base 10 of 85 minus log base 10 of 17 plus 1/2 of log base 10 of 400. So there's a lot of stuff going on here. Let's just break it up into some pieces. Let's start by doing the subtraction here and rewriting that as a quotient. So this is really equivalent to log base 10 of 85 over 17 plus, now this 1/2 I'm actually going to bring back up as a power. So I'm going to use that power property in reverse as well. This really says log base 10 of 400 to the 1/2. Now remember, 1/2 power is the same thing as square root. So it's the square root of 400 here. So let's rewrite this one step further, and I'm going to simplify 85 divided by 17 is 5. And I'm going to simplify the square root of 400 to be 20. So now I have an addition of log base 10 of 5 and the common log of 20. And I'm going to use my product property in reverse and say that this is really equal to the common log of 5 times 20, which is 100. Well, in other words, what power do I raise 10 to in order to get 100? This again is equal to 2. So my original equation, which says log 85 minus log 17 plus 1/2 log 400, is really equivalent to just 2. All right, our final example here. And again, we got a lot of things going on. This 2 out in front of the log really came from that power, that exponent on 8. So this is log of 0.5, or 1/2, 8 squared, minus log base 0.5 of 2 to the 4th. And since we have a minus sign, this is really meant that this was a quotient property. So let's rewrite this as 1 log. So this is log 0.5 of 8 squared, which is 64, over 2 to the 4th, which is 32. Now I'm going to simplify a few things here. This 64 over 32 is really 2 over 1, and this log of 0.5 is really 1/2. So what power do I raise 1/2 to in order to get 2? Or think about it this way. What power do I raise 1/2 to in order to generate 2 over 1? I'll let you think about that, and you can tell me tomorrow in class.